Mr. Wright. Today we're going to look at the angle addition postulate, and we're also going to talk about congruency. So the angle addition postulate states that if you have two angles next to each other, they have like a shared side. Pretty much you can add those two angles together to figure out what the total angle is. So for example, in this picture, if I just estimate what these angles are, let's say like this angle is 13 degrees and this angle is 14 degrees. Because they have a shared side, they're adjacent to each other, I can actually just add those two numbers together and say that the entire angle would be 14 plus 13 would be 27 degrees. So when you're showing, or like on your paper, how to represent multiple angles, what you want to do is draw an arc. I like to do it kind of near the outer part of the angle to show that those two angles together would be 27. So let's look at an example. So in this example, we have point P is on the interior of angle OZQ. So anytime in geometry we have a problem like this, we want to draw a picture first. So this one is saying we have an angle OZQ, and point P is in between OZQ. So what that means is like you have another line in the middle of the angle that goes through point P. So after that, you want to add the numbers to the picture. So it tells me that OZQ, which is the entire thing, both angles together, is 125. So the way I'm going to represent that on my picture is I'm going to draw a big arc kind of near the outside to show that those two angles together are 125. The next piece of information they tell me is that OZP is 62. So if I follow the letters O to Z to P, that is the top angle. So if it's just like a single angle, I'm going to just add that number inside, just like near like the center of the angle. So what we're trying to figure out is what is the measure of angle PZQ. So PZQ is the bottom angle. So you want to add something just so you know like what you're trying to find. So after we draw the picture, then you kind of just analyze how would I solve this. So if I know that both angles together are 125, the top one is 62, then in order to figure out the missing piece, I'd have to subtract. So 125 minus 62 would be 63 degrees. So the picture makes it a lot easier to solve than just trying to read through that, and like it would be very confusing if I didn't have a picture. All right, another thing we have to go over today are congruent segments and congruent angles. So this symbol right there is my congruent symbol. So congruent means two things are going to be the same. So it could be like two angles are the same, two side lengths are the same. We don't say equals because when you have like an equal sign, it's typically with like a number. So congruency signs are going to be like two things, like an angle or a segment. So within segments, if I have two segments that are congruent, like AB is congruent to CD, you use tick marks to represent congruency in pictures. So if two segments both have one tick mark, that means those two segments are congruent. If segments have two tick marks, those two are congruent. If you have three and three, they would be congruent. So if they have the same number of tick marks, those two segments are congruent, which means they're equal. In angles, you use arcs to represent congruency. So if angle TUV is congruent to angle XYZ, then they could both have one arc. If another set of angles are congruent, they could both have two arcs. Another way sometimes you'll see this is if I have two congruent angles, sometimes you'll see like tick marks on an arc, and that pretty much means the same thing. It just means that those two angles would be congruent. So let's see how we can apply some of this angle addition postulate as well as congruency marks. So if I'm looking at this picture, I notice in the picture I have two congruency marks. This one and this one tells me that those two angles are going to be the same. So if one angle is 32, the other angle is 32. The next thing we want to do is add any other information. So this one tells me the measure of angle WXWZ is 127. If I look at my picture and follow those letters, that means all three angles together are 127. So I'm going to do that near the outer part of the angle to show like all three of them together. So what we're missing is just that middle angle, and that's what we're trying to figure out, YWV. So this is another one where you would have to subtract in order to figure out the missing piece. So I would know all three are 127. Then I have a 32-degree angle and another 32-degree angle. So that would leave me with 63 degrees. So the middle piece would have to be 63 degrees. Easy way to check this, you could just add all three and it should equal 127. Here's another example that would have congruency marks, and we have to use our angle addition postulate to solve it. So I noticed in my picture that these two angles are congruent. I don't know what they are yet, but I know that they're going to be the same. So let's add the other information. The measure of angle NOP is 31. So this is 31. The measure of angle NOQ is 114. NOQ, so that's all three angles together, so I'm going to do a big arc. What is the measure of ROQ? So we're trying to figure out what one of these angles are. All right, so what I would start off by doing is subtracting those two. So I'm going to subtract 31 from 114. That's going to give me 83 degrees. So if just NOP is 31, that means that the other two angles together have to be 83. So that's not my answer, but I know that both of those are 83 if I add them together. But my congruency marks tell me that they're going to be the same measure. So if they have to be the same measure, I can just do 83 divided by 2, and I would get 41.5. So if they're the same, each one would be 41.5, and that would be my answer. So the angle ROQ is 41.5 degrees. So no two problems, like they're not always going to be the same setup, or it's not always going to be the same process. That's why you have to like look at your picture, analyze it, come up with a plan in order to solve it as you go along. All right, so then we could also have congruency marks within like on segments. So if I have a picture like this, what I'm looking for is like if there's one congruency marks, my picture tells me that that means it's 8 centimeters. So that means my other spots where there's one congruency mark is 8 centimeters. If there's two congruency marks, it means there's 11. So that's 11 centimeters. So in this example, what is HF? That's from there to there. I now have enough information to answer that, because those two pieces together would be 19 centimeters. So that would be the answer. So the big idea there is just making sure that if it's the same number of congruency marks, those sides are going to be congruent.